Hey guys, today we're going to be taking a look on how to find the distance of a point from a line. So on the left side, you see that I've drawn the coordinate plane with the y and x axis. The line is ax plus by plus c equals 0. We have point P and the x coordinate is x1, y coordinate is y1 for now. And we're trying to find the distance between this point P and this line. And that is basically saying what is the length of line segment PN. And you can see that when I drew this line segment PN, it forms a 90-degree angle with this line segment and this AX plus BY plus C equals 0 line. Now, why is that? Well, whenever you're asked to find the distance of a point from a line, it's always asking, let's say you drop a perpendicular from the point to that line. What is the length of the perpendicular? That is what it means by distance. When it means by distance, it means length of the perpendicular. So I'm just going to abbreviate that for short. So it's saying length of the perpendicular. So it does not mean this. It does not mean find the length of this, since when it reaches the line, this is obviously not perpendicular. So instead, it means this, PN. So we have to find the length of line PN. If we find the length of line PN, well, then we have found the distance of a point from a line. Well, the formula for finding the length of PN is equal to the absolute value of AX1 plus BY1 plus C over square root A squared plus B squared. So that is the length of PN. But you might be wondering, what is with these absolute value signs? Like, why are they there? Do they mean anything significant? Well, yes, they actually do. Well, because you might get a negative value when working with whatever's inside. But we obviously know that since it's distance, it has to be positive as well. So that is why these absolute values signs are there. Now let's start off with example 1. So we have the formula to finding the length of PN. We saw the length of PN is basically just this line segment right there. Now let's take a look at the example. Example 1. Find the distance between the line 12x minus 5y plus 9 equals 0 and 2, 1. So chances are 2, 1 is probably going to be over here. Let's just say this is 2, 1. The line is probably going to be here. This is not accurate. It'll help you guys visualize. This is 12x minus 5y plus 9 equals 0. So they're asking if this is P and we drop a perpendicular and this is N, what is the length of PN? Well, first we need to identify our A, x1, B, y1, and C values. A, we know is 12 from over here. B, we see that's negative 5. C, we see that's 9. X1 is the x coordinate, which is 2. Y1 is 1, which is the y coordinate. Now we have A, B, C, x1, and y1. Now we are all set to put it into this formula. So Pn, the length of Pn, is equal to the absolute value of Ax. A we saw was 12, x1 we saw was 2, plus y1. B we saw was negative 5, y1 we saw was 1, plus C. C is 9. Over square root A squared, 12 squared, plus B squared, negative 5 squared. Absolute value closed. Simplifying the top, we have 24 minus 5 plus 9. Simplifying the bottom, we get 144 plus 25, which is 169. Further simplifying this, we get the top part is equal to 28. The bottom part is equal to 13. And now we see that, well, 28 over 13, well, we take the positive value of that, which is just 28 over 13. Therefore, the length, the distance between the line 12x minus 5y plus 9 equals 0 and 2, 1 is 28 over 13. Alright, so let's take a look at another example. So once again, we have the same formula. Example 2. if P is the length of the perpendicular from the origin to the line x over a plus y over b equals 1, then prove 1 over p squared equals 1 over a squared plus 1 over b squared. So let's break this big problem down into chunks. They're saying if p is the length of the perpendicular from the origin, meaning 0, 0, to the line x over a plus y over b equals 1. So let's find p. Let's break it down. So how do we find p? Well, they're basically saying find the length of the perpendicular from the origin to this line. Origin is 0, 0, and this is the line. Well, let's rewrite the line. Let's rewrite the line in standard form. So that's basically just saying 1 over ax plus 1 over by equals 1. And taking 1 to the other side, we get 1 over ax plus 1 over by minus 1 equals 0. So that is the equation we are going to use, and we have our origin, which is 0, 0. Now we plug it in here. So we're going to find the length of the perpendicular starting from 0, 0 and dropped onto this line. So now we have the length is equal to the value of a, which in this case is 1 over a, absolute value of 1 over a times x1, which is 0, plus b, which is 1 over b, y1, which is also 0, minus c, which is negative 1, over a squared plus b squared. In our case, a squared is 1 over a squared, and then b squared is 1 over b squared, closing that absolute value. Simplifying this, the top we're just left with negative 1, bottom we are left with 1 over a squared plus 1 over b squared. Further simplifying, we can simplify the bottom as well, saying negative 1 over square root b squared plus a squared over a squared b squared. This bottom part we can take out. That's saying negative 1 over square root b squared plus a squared times 1 over ab. Once again, this is simple algebra, so we just took this out of the square root. Now we have 1 over ab. That's the same thing as saying minus ab square root a squared plus b squared. I'm just switching the b squared and the a squared around, but overall it still means the same thing. And now, since it's absolute value, let's just get rid of that negative sign, so we are left with ab over square root a squared plus b squared. This is the value of p. Now that we have the value of p, we kind of already discussed the first part of the problem. Now they're saying prove 1 over p squared is equal to this. Well, we already found p. Let's just take 1 over p squared. P squared. We know p is ab over square root a squared plus b squared, as we just found it over here, squared. Further simplifying this, we get 1 over a squared b squared over a squared plus b squared. Once again, taking this to the top, we are left with a squared plus b squared over a squared b squared. And finally, simplifying this, we're left with 1 over b squared plus 1 over a squared. Taking this part and putting them into two terms. So therefore, we have proved 1 over p squared is indeed equal to 1 over b squared plus 1 over a squared.